Okay, here are the solutions for Tuesday night's homework. So this was the first problem, and you had a picture that looked something like this. And the first part, part A, is to find the area of the region R. So the area is equal to, sorry, that was JoJo growling in the back. She wants my attention. All right, so the area is always going to be the integral, of the top minus the bottom dx. And JoJo, so for this one, okay, what is the smallest x value that's over here? That's 0. Oh my goodness, I have to give her a treat. Hang on. Okay, I gave her a treat. That should give me about 3 minutes. Okay, so it's going from 0, because according to the picture, that's 0. And over here, this is when x is 2. So it's going from 0 to 2. And then the top function, so the top function would be this piece right here. And that top function is coming from y equals 6, which they gave you. Okay, so we have the integral from 0 to 2 of 6 minus the bottom function. The bottom function is this line right here, which comes from that. So it's going to be minus 4 ln of 3 minus x. Sorry if you hear that noise in the background. That's my dishwasher. There's a lot going on here. Okay, so this is a calculator question. You're going to put this all in your calculator, and you should get 6.816. And the point values were as follows. If you set up the integral, that was worth 1 point, and then if you found the answer, that was 1 point. Okay, now we're up to part B, which is asking for the volume. So remember, in general, the volume would be pi, the integral, and then you'd have the top squared minus the bottom squared dx. Okay? So our picture, so I'm just going back to the picture for a minute. It is revolving around the line y equals 8. Now, since this is y equals 6 over here, that means it's revolving around a line up higher than that. So that would be like over here. Okay, so that means it's going this way, up. So instead of doing top minus bottom, we're going to have to do the bottom minus the top, because it's going up in that direction. Okay, so we're just going to change this to pi bottom squared minus the top squared dx. And JoJo's back, so you're probably going to hear some barking. Okay, so now we can start filling this in. So we have pi, and we need our integral. It's still going to be from 0 to 2. That didn't change. Okay, so the bottom function is now the 4 ln of 3 minus x. So it's going to be that squared minus the top, which was just the y equals 6. So it's going to be the 6 squared dx. But we're forgetting one little thing, because it's going around the line y equals 8. So in another video I had made, I had said that if it's going around a line other than the axes, you have to get it back to the axes. So how would you get 8 back to the axes? You would have to subtract 8. So where are we going to put that? Inside here. So it's going to be that function, and then minus 8 squared. And then we're going to do the same thing over here. So it's going to be 6 minus 8 squared. So that's the setup. Now, even if you screwed this up and you did it in the reverse order, it's not going to matter because everything is squared. So if you did it the opposite, you would just have a negative number, but a negative number is squared anyhow. It doesn't really matter. Okay, so then you're going to put all this into your calculator. And when you do, you're going to get this final answer, 168.179. So let me give you the point values for that. For the integral, that was worth 2 points, and then the final answer was worth 1 point. Okay, now we're up to part C, and as soon as I see the word cross-section, I'm going to do an integral. I'm going to write area of cross-section so I don't forget what to do. Then I'm looking to see what it's perpendicular to, and it's perpendicular to the x-axis. So therefore I have a dx, and then I'm going to have an x here and an x here. So we already know our x's go from 0 to 2, so that was easy. And now we're going to look at the shape. So we're looking at a square. Okay, so the area of a square is going to be the side squared. Well, what is the side? I'm going to go back. A side is just going to be like this. So it's going to be the top minus the bottom will give you each of these pieces in here. Okay, so the top is 6 minus the bottom, which is 4 ln of 3 minus x. Okay, so this represents one side, so I'm putting it over here for s, and then I have to square it. So I'm going to take this piece here, because that's my area of the cross-section, and I have to put it in over here. Okay, so I'm going to take this out. I'm going to have 6 minus 4 ln of 3 minus x, and this whole thing is squared. And this is asking you to find the volume, so we actually have to put this into our calculator. So you're going to use this. Most of the time they just say set up, but don't evaluate. When you put in your calculator, you're going to get 26.266. Okay, and the point values were, this integral was worth 2 points, and then the actual answer was worth 1 point. Okay, so that completes the first problem. Okay, so for part A, we need to know, when does G have a horizontal tangent line? So when is the slope equal to 0? So we want to know, when is G prime equal to 0? That's the question. Okay, so they gave us G prime, and G prime is sine of x plus 1 over x. That is G prime, so we want to know, when is that equal to 0? It's a calculator question, so you're going to put that into your calculator, and you're going to find out that x equals 0.163 and x equals 0.359. And they had said this is in the interval from 0.12 to 1. So both of these values are in that interval. And so let's see, the point values for this were, if you just took G prime and set it equal to 0, you didn't even have to solve it, you got 1 point. And then if you found these two answers, you got 1 point. Okay, that was part A. Part B wants to know, when is G concave down? So G is concave down when G double prime is less than 0. Now they gave you G double prime. Just get that out. G double prime is 1 minus 1 over x squared times cosine of x plus 1 over x. So that's G double primes. They gave you that, so we're going to set that equal to 0. Okay, again, you're going to use your calculator, and you're going to find that x is equal to it's one too many signs here. Okay, it's 0.12946, and x is 0.222734. Okay, so to know if it's concave down, we're going to make a wiggle graph, so I'm going to move this. Now remember, you can use a wiggle graph for yourself, but you can never say on the AP test because of the wiggle graph. We're just really doing it for ourselves. So G double prime, and we're going to put our two solutions on here. And then we're going to try different values. And when you do, you don't have to try anything over here because we only had to do it in the interval from point 12 to 1. So anything over here is smaller than point 12, so you don't have to worry about that. And so when you put values in, you're going to get a negative here, and you're going to get a positive here. And the question is asking when is it concave down? So that means it's concave down in here. So let's make some room, and we're going to write a concluding sentence because it does say justify your answer. And you're going to say, since G double prime is less than 0 in the, wait, let me make it a little bit shorter. Since G double prime is less than 0, G is concave down in the interval 0.12946 to 0.222734. I mean, you could word it a little differently. You could just say it's concave down in this interval because G double prime is less than 0. Okay, so what were the point values for this? If you got the answer, that's this, that was worth 1 point. But if you said it was because it was G double prime is less than 0, that got you 1 more point. Okay, now for part C, we have to write an equation for the tangent line. So right away I'm starting like this. And they want to know when x is 0.3, so I can put that in there. Okay, now we need to figure out what y is. Now we know that x is equal to 3, and we need to figure out what y is. So this is where it's going to start getting a little bit more difficult. So we don't know what the original function is. So we know if we do the integral of g prime of x, going from something to 0.3, that will give us the answer. So going from what? Well, they told us that g of 1 is equal to 2. So we're going to go from 1 to 0.3, but that means we started at 2. So that's the initial condition. Okay. However, you can't have the bigger number of 1 on the bottom, so we're going to have to switch that around. And we're going to get that. Okay, so you're going to put this into your calculator, and you're going to get 1.546007. Okay, so that is your y value. So y minus 1.546007. I know that's kind of long. You probably don't need all those numbers. Equals m times x minus 0.3. Okay, the next thing we're going to need is m. Remove this. Okay, so m is just the derivative, right? And we were told that the derivative is sine of x plus 1 over x. But we're interested in the slope when x is 0.3. So you're going to get sine of 0.3 plus 1 over 0.3. You're going to put that into your calculator, and you're going to get negative 0.472. So that's our m. Okay, and that is our tangent line. Okay, so the point values for this were, if you found g prime of 3, that was this number over here, that was worth a point. If you did the integral, which I erased, in order to find what g of negative 3 is, g of 0.3 is, when we use that initial condition. So that was worth 2 points. And then if you actually got the equation, that was worth 1 point. Okay, and finally part D. So does the tangent line to the graph lie above or below the graph? All right, so here's how you would know. If my picture is concave down, here's my tangent line. Tangent line would be above the graph. If I'm concave up, then my tangent line would be below there. So we really want to know is the function concave up or concave down at x equals 0.3. So we need g double prime because that tells us about concavity. So we want to do g double prime of 0.3. But they gave us g double prime, so this is all going to be calculator driven. So we get 1 minus 1 over 0.3 times cosine of 0.3 plus 1 over 0.3. Okay, so you're going to put that into your calculator and you're going to see that you get a positive value. So this thing is greater than 0. So your explanation is going to be, since g double prime of 0.3 is greater than 0, g is concave up, therefore the tangent line is below the graph of g. And that was worth 1 point for that. Okay, that finishes the second one. Okay, now we're on to number 3. So 3 looks very confusing from the picture, but it's not that terrible. Okay, so for part A, it's saying use a midpoint Riemann sum with 3 intervals of equal length. So we're going to have to use from 0 to 4, from 4 to 8, and then from 8 to 12. So we're going to do this 3 times. So a midpoint is a rectangle, so the length of each of these is 4, so we know it's going to be 4 times something. Okay, and now the midpoint between 0 and 4 is 2. So you're going to look at your table, and at 2, you get 46. The midpoint between 4 and 8 is 6, so you're going to look at your table and get 57. And then the midpoint between 8 and 12 is 10, so you're going to look at your graph, and you're going to get 62. Okay, so I'm going to work out these numbers. We add this all up and we get 660. And so the question is asking for the total amount of water that was dumped in there. So you're going to get 660 feet cubed. Okay, and our point values for this was, if you did this part over here, you got 1 point, and then if you got the final answer with the units, that was worth 1 point. Okay, let's go to part B. Okay, how much water leaked out of the pool from 0 to 12? So you know you're going to do an integral from 0 to 12, and how much water leaked? Well, that was R of t. They told you in the story. They said water is leaking from the pool at a rate R of t. Okay, so R of t dt. You can write that, or you could have written the 25e to the negative 0.05t. In any case, you're going to put that into your calculator, and you're going to get this, 225.594. The amount of water that leaked, so it's going to be that feet cubed. Okay, and the point value was 1 point for setting up this integral, and then 1 point for the answer. Okay, for part C, use your results from parts A and B to approximate the volume of water in the pool at t equals 12. Okay, so in the story, it told you that time t equals 0, you already had 1,000 cubic feet of water. So you started with 1,000, and then we had to add, right here, the 660. But then you need to take out the water that was leaking out, and that was the 225.594 over here that we just found. So you're going to combine all those values, and you're going to get 1,434.406. And the question is saying to round your answer to the nearest cubic foot. So this would be approximately 1434 feet cubed. And this entire thing, doing that, well, they're just saying the answer was worth 1 point. Okay, finally we're at part D, and this is the part that's, pretty difficult. So even if you can only do parts of this, you're still in good shape. Okay, find the rate at which the volume of the water is increasing at t equals 8. Okay, so they gave you R of t, and they talk of P of t, and those are already rates. So we can say that the rate at which the volume, so that's dv over dt or v prime, whichever way you like better, would have to equal P of t, which is the water going in, minus R of t, which is the water going out. Those are already the rates. So we need that at t equals 8. So we're looking for P of 8 minus R of 8. And P of 8, when you look on your table, that's equal to 60, minus R of 8, so you're just going to put 8 into the R function, which is 25e to the negative 0.05t, but we're going to put 8 there. Use your calculator for this, and you're going to get 43.241 feet cubed per hour. And for that, the point values, you only got 1 point for doing this. Okay, but next, the second part to D is how fast is the water of the pool rising? So I'm going to go to the screen. So how fast, that's the find. How fast is the water level, so that's the height. So we're going to find dH over dt. That's our goal when t equals 8. And they were nice enough to tell you in the story that volume is equal to pi r squared h. Okay, the only thing is that this would require a product rule. We're never going to be able to solve this because there'll be too many things going on. But in the picture and in the story, they're telling you that the radius is 12. Now, if it's in the shape of a cylinder, that means that's a constant. The radius is always 12. So we can substitute r for 12. And we're actually going to get the volume is 144 pi h. Okay, so we're trying to find the derivatives here. So we're going to get dv over dt equals 144 pi dh over dt. Okay? Now here's the thing. We're trying to find dh over dt. So we need to move this 144 pi over to the other side, which is what I'm going to do. So 1 over 144 pi, so let the dv over dt equals dh over dt. Okay, so now we're supposed to find this when t equals 8, but you can see that there's no t here. But what we can do is dv over dt is just the derivative, and the derivative is, do I still have that other screen? Yes, I do. It's right here. Derivative is just P of t minus R of t. So I'm going to go back. So the derivative is P of t minus R of t. That's going to be our dv over dt. So if we are interested in when t equals 8, then you're just going to put 8 into all of these things, but we already did that. We got this, 43.241. So this whole thing is 43.241 1441. So we're going to take this, put that right in there. Okay, and so you're going to have 1 over 144 pi times 43.241 equals dH over dt. So you're going to use your calculator, and you're going to get that dH over dt is equal to 0.0955835. It says indicate units of measure. This is going to be feet per hour. And the answer was worth 1 point, and the units was worth 1 point. And that finishes the homework.